All right, let's get into the last question, then I'll kind of hop back in with you guys in on the chat. So last one is to graph. Now this is actually one we're going to be getting into my class period. And so there's a couple different ways. It really kind of depends on how much you need to know for graphing or how like specific you need to be. You know, I graph these without my calculator, so, or at least I ask my students to be able to do that. So, you know, I do make sure that they understand, you know, how to identify certain things. So I think the first thing that we should be able to understand for any function is that to find the x and the y-intercept. So the x-intercept, again, is when y is equal to 0, or f of x, right? It doesn't, you know, those are interchangeable. It just depends on the notation. So if I put 0, and then I have x over x squared minus 25, well, obviously now to solve for x, I'm going to have to get the x squared minus 25 off the denominator, so therefore I'm going to get x is equal to 0. All right, to find the y-intercept, that is when x is equal to 0. So therefore, I'm just going to take my f of x, or let's replace it with y. So I'll say y is equal to 0 over 0 squared minus 25, which is just equal to 0, right? Anything 0 in the numerator. So therefore, I have an x and y-intercept at 0. Good. The next thing would be identifying the asymptotes. The vertical asymptotes, all right, are going to occur at x squared minus 25. So therefore, that's going to be when the values are going to x squared minus 25 is equal to 0. So therefore, we can say x is equal to plus or minus 5. And then we have a horizontal asymptote. The horizontal asymptote is, again, maybe going to be a comparison of our degree in the numerator over our degree in the denominator. Whenever the degree in the denominator is larger than the degree in the numerator, we have a horizontal asymptote at y is equal to 0. All right, so now I have quite a bit of information. I have two vertical asymptotes. I kind of have an idea what this is going to look like, but I'm also going to kind of verify that to make sure. So I have a x and y intercept. Okay, and then I have some vertical asymptotes, and I have a horizontal asymptote. Okay, so the best thing here now would really just to kind of like pick some points, right? Use a table of values. Obviously, if you're used to what the graph would look like I have an idea it's going to be that, upside down parabola, and like that. But let's go and take a look. So again, let's just pick some points, you know? Like the best thing also about graphing for any function, doesn't matter what it is to just pick points. Like use a table of values. So let's make f of x. And actually, to preference that, a lot of times when I used to spend more time with graphing with my students, all I really asked them to do would, you know, basically be able to identify, give me a point to the left and to the right of every single intercept, okay? Or every single asymptote as well. So let's go ahead and do that. If I was going to, again, I want to pick something that's going to be kind of nice, and that doesn't really, yeah, it's whatever. Let's do it. All right, so we have fx and then we have x. All right, so let's pick -6, there's 5. Let's do -4. Then let's do to the left and right of that, let's do +4, and let's do +6. Okay, so therefore I'm picking 2 points here and then 2 points there, and I think that should hopefully give us an idea of basically what's kind of going on. Because again, we have this asymptote here, and we have these two asymptotes. So at -6, that's going to be, you know, -6, that's going to be 36, minus that's 11, so that's going to be a -6 over 11, okay? At -4, when I plug in a -4, that's going to give me a, so that'd be -4, so that's going to be a, so that'd be 16 minus 25, so that's going to be -9, so that's going to be a +4/9. If I was going to do +4, I bet that's going to be positive as well, which it's not. That's actually going to be a -4/9. And then if I did a +6, +6, that's going to be a +6/11. So basically, if you wanted to kind of identify the graph a little bit more, you just want to plug in some more points, right? And kind of see what it is. Now, for the sake of this live stream, I actually didn't do this problem ahead of time to look at it. So I'm just going to go ahead and cheat because save everybody some time and just say, let's look at this. Because obviously these points, you can just kind of judge them as far as how close they are to 1, and certain values that you're aware of. But, basically you can just keep on picking points, like pick -7, pick -3, pick -2, and just keep on doing that until you have an idea of what you're looking at. The best thing that you can understand with this is that, remember, the asymptotes, the function is going to be approaching the asymptotes, right? They can cross a horizontal asymptote. They're not going to cross a vertical asymptote, but they're always going to be approaching those asymptotes on the end behavior. -25. So it's close. So it has that cubic form. Yep. Okay. That's what I was. So on this one, it looks something like this. So I was right with those. It's actually going to have this S-curve shape. And then has this little hyperbola one here. So again, that makes sense, right? Because at -6, we had a negative value. At -4/9, we had a at -4, is that supposed to be? Oh, at -4, so we had a positive, right? At +4, we had a negative value. And at +6, we had a positive value. So you see how that kind of works for that graph. And again, to really kind of define that is just, again, picking more points from this table set and then plotting them on the graph, and going from there. But I think with technology nowadays, we can spend a little bit more time using obviously graphs, calculators and stuff. So that's why I don't really spend as much time with my students. But I do make sure that they can identify the x-intercepts, the y-intercepts, horizontal asymptotes, and vertical asymptotes, because then the rest of it's just plugging in points and, seeing what you come up with.